In part one of this series, The Secrets of the Gaussian, I discussed the starting point for analytics, that is, the histogram. The frequency table was the tool used to create the chart. I also mentioned the bell and why it was referred to as the beginning of the bell curve. The frequency table is used to create most of the charts that you could use for your operations. These charts can represent curves, which represent data in a visual form. In this part 2, these curves are presented in a little more detail. I'm Rob Boyko, Boyko Mineral Exploration, and welcome back. The J-curves, sometimes referred to as the hockey sticks, are the simplest of the curves to understand and visualize. The frequency table is easy to build. If you started your placer mining operation, for example, in the start of May, and you recorded all your samples for each day and plotted them, and on the first day you had 1 troy ounce per ton recorded, and you did this every day until the end of September, when you shut the operation down for the winter season. You can now go back and analyze the findings. In our hypothetical chart, you can easily visualize an increase in the troy ounces per ton. You started with 1 troy ounce per ton at, let's say, 2 feet down from the till. And at the end of September, you ended up with 5 troy ounces per ton at the 3-foot mark. After looking at your chart, would you continue working that same piece of ground? I know I would. At $1,800 per ounce, the price, of course, would depend on the purity of the gold extracted, of course. $1,800 is the bullion price of gold at 5/9 pure. That was at the time of this presentation. The reverse J is similar to that of the forward J. The difference here is that the reverse J usually represents or shows visually a downward trend. Putting it into perspective, as shown, in the following year, let's say you started your operation in the same location. You recorded your results at the end of each month until you shut down for the winter season. If your graph was similar to the one shown, your output in gold per troy ounce shows that it has dwindled down to 1.2 troy ounces per ton. Would you continue working that same site next year, or would you reclaim and test an adjacent location? Myself, I would be considering the latter. These last 2 slides were simply hypothetical examples of what these curves represent and how they may be useful in your operations. So let's move on. The U-curve is a little different. In this example, I hypothesize operating costs in thousands of dollars. Now these are just figures for ease of understanding. Now these figures span over a period of 9 years. Operating expenses include all purchases ranging from new equipment to gas and propane to food and, of course, lodging. Let's say you started fresh at year 0 and recorded your initial expenses and continued recording throughout the years. Now let's say you started with new equipment, etc. Well, if you did, operating costs should go down, but as time goes on, trends change. This is due to a number of factors, everything from inflation to maintenance. After a few years, you notice you're spending more than you are actually making in your mining operation. Well, this graph shows the trend in operating costs. If this was my operation, I would be trying to figure out why I am spending more at year 6. In most cases, as equipment starts to age, the maintenance costs start to rise. And so does inflation. No operation is worth losing your shirt over. When it comes to buying or selling a claim, or even considering staking a claim, the ground should be proven. This is done statistically. with a combination of analytical sample concentrations and statistical analysis. These statistics are plotted on a graph to visually show the estimated potential of what may be in the ground, sometimes referred to as the lot or the population. The analytical concentrations must accompany the graphs. This data should be freely given to a potential buyer, that is given out by the seller. As a buyer, I would be asking for the laboratory analysis certificate which confirms the estimated analysis of the graphs. These are what would be considered proofs. Now, if you were to stake a claim, this data can be obtained by you in the form of samples, which you may analyze yourself or send to an assay laboratory. The curve that is most often used for this purpose of proofs is the bell curve, which is also known as the Gaussian. When you first start plotting the graph, it will be skewed. It represents what you have, but will not be accurate in estimation of what the ground actually contains. I have shown in the last presentation, that is presentation 1, the histogram, that the more samples acquired, the more accurate the data will be in terms of your total estimation. Remember the nugget effect. If I was to buy a claim and the seller was telling me that the claim is estimated to contain 4 troy ounces of gold per ton, I would be asking for the proof of statement. That would include the graph, all assay results from the sampling, etc. There are too many scammers out there. Some will just acquire claims for resale without proof. If the seller does not have the proof or is not willing to allow you to do some sampling on your own throughout the claim area, then beware. So let's look deeper into the bell curve by discussing the mode, the median, and the mean in simple terms. When you start plotting your test results, your graph will probably be skewed. The mode line represents the total amount of samples acquired that contained a high concentration of gold. Hypothesized 24 samples yielding 6.8 grams. That is the highest frequency as represented on the chart. The point along the chart is referred to as the mode line. The range is simply that, the range of concentrations obtained from the samples. Hypothesize 1 gram to 10 grams. At 5 grams, a line would be drawn which represents a center of the range between 0 and 10 grams. This is the median line. The mean line is the average concentration calculated from the total concentration added up, which is obtained from all of the samples. Neither of these lines or points line up. This indicates what you have obtained, but does not mean that the concentration in the ground equates to what is actually there. This is a result of the nugget effect. The graph only shows what you obtained, not what might be in the ground. With more and more data being entered into the frequency table, the range of concentrations will start to fill in. Instead of having gaps in the concentration range, the gaps will start to fill in. The skewed bell will start to appear more like a true bell. As this transformation begins to happen, the mode, the median, and the mean lines will merge together. When this happens, the graph becomes quite accurate in the estimated representation of what you have in total as an estimate. Before going into more detail, I need to explain a couple of terms that will be used going further. The lot, or population, both mean the same thing. The area map is the location map of a claim. In this instance, it is 6 cells in size. The site map is the location of the working area within the claim. The lot, or population, represents the ground that you are working. The hole or excavation that you may be digging is hypothesized as being 20 by 10 by 20 feet as shown. All the dirt is referred to as the lot. The samples or gold that you may be taking from this pit is being taken from the population, and all estimates are based on this lot of dirt. This lot, when fully dug out, may be 3 tons of material. This is something that needed to be clarified. These terms are interchangeable and will be used from now on. So let's continue. Think of the bell curve as the lot. The x-axis is the concentrations derived from the many samples taken from that population. The y-axis is the number of instances recorded for each sample concentration. Along the x-axis is the range of concentrations, which would all be listed. All the concentrations along the x-axis from infinity to infinity represents 100% of that population. The mean, median, and mode lines are all in line. The center is now the average concentration of all the recorded samples. From the mean, there are zones. To the left, these are represented as the negative zones, and to the right are positive zones. The mean is referenced as the 0 line. These zones are referred to as the standard deviation. They represent the range in either direction from the mean. This will be explained in part 3 of this presentation. Now focus on the values of infinity to infinity. Hypothesize that the mean has a value of 400 parts per million. Then minus 10 would equate to 300 parts per million, minus 20 would be 200 parts per million, and so on. Anything below minus 30 would be values below 100 parts per million. The values above the mean would be 500 parts per million, 600 parts per million, 700 parts per million, and anything from infinity would be value greater than 800 parts per million. What is shown is that 99.73% of your values will fall within 3 standard deviations. The concentrations between 300 and 500 parts per million will be estimated at 68.268% of the lot. 34.135% of the population will have concentrations of 300 parts per million to 400 parts per million. Concentrations ranging from 100 to 200 parts per million will only be 2.14% of that population. This graph and the accompanying data will and does constitute the proof in regards to the selling and the buying and or the acquisition of a claim. This shows what you can or may expect in regards to the mining of the commodity that you are after, whether it would be gold, silver, manganese, or anything else of industrial value. In this presentation, I introduced you to the curves that may be produced from the frequency table and how they may be used in your operations. I focused a bit more on the bell curve, which is also called the Gaussian curve in statistics. This is an important tool to use when estimating the concentrations of precious metals or industrial metals on a claimed area. Large mining companies do this for monetary purposes or to prove that the claimed area is viable for the mining. If they can't make a profit, they will not start mining operations. Many mining companies have disappeared due to false estimates. As a small-scale miner or prospector, you will not want to make that mistake. If you are going to market your claim, you will need to show proof. Some sellers have actually been sued and even charged criminally for falsifying a claim. As a buyer, ask for the proof, and if none is available, ask for permission to sample the entire area and get as many samples as possible and have those analyzed and recorded. It becomes easier to obtain samples when you're prospecting and are going to stake a claim, but only stake if the numbers are there. You do not want to throw good money into the wind. In the next edited video presentation, titled The Numbers, I will be showing how the numbers are calculated and how they fit into the curve. I will be discussing subjects such as the mean, the standard deviation, relative standard deviation, and a couple of checking calculations for verification. If you like this presentation and know of someone who may benefit from this presentation, please give it a like, a thumbs up, and a share. It's my only reward. I am Rob Boyko, Boyko Mineral Exploration, and I thank you for watching.